Good day everyone, I'm Shiela Mae Chua, your reporters for today's video discussion. Here's the learning objectives. At the end of this lesson, the student should be able to understand the binary numbers, understand the operations on binary numbers, learn how to apply the addition, subtraction, multiplication, and divisions on binary numbers, learn how to carry over bits and borrow bits, and to understand the binary operations involving the negative numbers, and lastly, to understand the sign bits and the sign magnitude. Here is the learning discussion. Before I discuss our main topic, I want to give you a brief discussions about the general one to specific or from general to our main topic. Let's start with what number is. A number is a mathematical value used for counting, measuring, and labeling. Numbers have various classifications and types, like the natural numbers, the rational numbers, and irrational numbers, etc., which is already discussed. Similarly, there are various types of number system that have different properties, like the decimal, binary, octal, and hexadecimal number systems. What do we call to those terms that we've heard? Yes, it's the four types of the number system. But is it only four? It's not. It is more than that. But these four are the most common types of number system. Why? Because they are superior to simple everyday math. But as we can see, the decimal number system is the most widely used by modern civilizations. Why? We use base 10 simply because we have 10 fingers, also known as digits. So now, let's tackle the first and most commonly used number system, the decimal number system. Now, when you hear the word decimal, what comes to your mind? Think of the prefix deci. What does it mean? Deci means 1/10. So deci is associated with 10. And in fact, the decimal number system is a base 10. The decimal number system contains 10 digits, the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, with a base number of 10. The decimal number system is the most common way of representing numbers in everyday life. Any number that is represented without a base, it means one thing. It is a base 10. For example, the number 85, 176, and 1619 are some examples of number in the decimal number system. The next one is our topic for today, and you need to be familiar with this, the binary number system. So when you hear the prefix bi, what do you think of? Bi means 2. So binary system is a base 2 system. Only 2 digits are used in the binary number system, namely the 0 and 1. In a typical digital computer, 0 means off, and 1 means that the system is in on state. Bits are the digits 0 and 1, and a byte is made up of 8 bits. Bits and bytes are used to store data in computers. Other numbers such as 2, 3, 4, 5, 6, and so on and so forth are disregarded by the binary number system. For example, we have 1000101001 and 11011001 are some examples of binary numbers. Next, we have the octal number system. When you hear the word octa, what do you think of? For me, I think of the octagon. An octagon is a polygon with 8 sides. So octa means 8, so the octal number system is a base 8 system and uses the following digits, the 0, 1, 2, 3, 4, 5, 6, and 7. This system has the advantage of having a fewer digits than other systems because it means there will be a less computational errors. And lastly, the hexadecimal number system. Now, what is meant by the prefix hexa? Think of the word hexagon. A hexagon has 6 sides, and so hexa means 6. And we know that decimal corresponds to 10. So when we combine them, 6 plus 10 is equal to 16. Therefore, the hexadecimal system is a base 16 system. The hexadecimal number system contains 16 digits and alphabets, namely the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and A, B, C, D, E, F. Let's tackle more the decimal number system, since understanding decimal will help us understand binary. Consider the number 789. We often say that 9 is in ones place, 8 is in tens place, and 7 is in the hundreds place, which makes these numbers equal to 7 times 100 plus 8 times 10 plus 9 times 1, all equal to 789. Now we can also say that this ones place is 10 raised to the power of 0. Tens place is 10 raised to the power of 1. And hundreds place is 10 raised to the power of 2. Each place represents a power of 10. And this is why this is the decimal number system from the Latin for 10. Let's proceed in knowing the decimal value of binary numbers. Why should we know, or why is it important to know the decimal value of binary numbers? Because it will help us to check if our answer is correct. In converting binary numbers, we will start multiplying by 2 from right to left, since binary is a base 2. Now let's start with 1. Then 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, 32 times 2 is 64, and 64 times 2 is 128, and so on and so forth. To find the decimal value of the binary number 10110010, we need to add all the decimal numbers with 1 in their column. So basically, because there is 1 under 128, under 32, 16, and 2, we will add all of them. So 128 plus 32 plus 16 plus 2 is equal to 178. So the equivalent decimal number of the binary number 10110010 is 178. Of course, we should also be able to convert the decimal number to binary number. Let's go ahead and begin. We will convert 178 into a binary number that will allow us to confirm our answer earlier. We said that 178 is equal to 10110010. So here is what you need to do. Start with 178 divided by 2. 178 divided by 2 is 89. So what this means is that it's 89 remainder of 0. 89 divided by 2 is 44.5. So what this means is that it's 44 remainder of 1. Then 44 divided by 2 is equal to 22, remainder is 0. 22 divided by 2 is equal to 11, remainder is 0. 11 divided by 2 is equal to 5.5, remainder is 1. 5 divided by 2 is equal to 2.5, remainder is 1. 2 divided by 2 is equal to 1, remainder is 0. 1 divided by 2 is equal to 0.5, remainder is 1. So we're going to read it from the most significant bit to the least significant bit. So from the bottom to the top. It's gonna be 10110010, which means our answer is correct. Now let's proceed in knowing what is fractional binary number. Similar to decimal fractions, binary number can also be represented as unsigned fractional numbers by placing the binary digits to the right of the decimal point, or in this case, binary point. So we can see that fractional binary numbers are binary numbers that have a weighting of less than 1 and can also be converted into their decimal number equivalent by successively dividing the binary weighting factor by the value of 2. Now let's go with knowing the decimal value of a fractional binary numbers. For example, we have 10011.1100. In converting binary numbers, we will start with a radix point or binary point, multiplying by 2 from right to left. Now let's start with 1 again. Then 1, then 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. And 8 times 2 is 16. Now we will start with a radix point again, or the binary point, dividing by 2 from left to right. Let's start with 1 again. Then 1 divided by 2 is 1 half. 1 half divided by 2 is 1 over 4. 1 over 4 divided by 2 is 1 over 6. And 1 over 6 divided by 2 is 1 over 8. Just like before, we're going to focus on the values that have 1. So we're going to add all the values that have 1 under, which is the 16 plus 2 plus 1 plus 1 half plus 1 over 4, which give us 19.75. Now that we tackle how to convert binary to decimal, decimal to binary, and binary with a fractional part to decimal, let's begin with our main topic, and it's all about the operations on binary numbers. Operation on binary numbers. A binary operation is an operation that requires two inputs. These inputs are known as operands. Operands are a quantity on which mathematical operations are performed. Addition, subtraction, multiplications, and divisions are binary operations that are performed on two operands. Let's start with the binary addition. Binary addition is the sum of two or more binary numbers. Binary addition is much similar to decimal addition, even a bit easier. Why? You just need to know the following rules for you to easily add binary numbers. The four rules of binary additions are 0 plus 0 is equal to 0, 0 plus 1 is equal to 1, and 1 plus 0 is equal to 1, and 1 plus 1 is equal to 1 0, because 1 0 is equivalent to 2 in decimal number. Why? Since we already have discussed the conversions of decimal to binary, let's do it here. So if you have 2, 2 divided by 2 is equal to 1, remainder is 0. And 1 divided by 2 is equal to 0.5, remainder is 1. So we will write it from the most significant to least. So from bottom to the top, which is 1 0. That's why 1 plus 1 is equal to 2, or 1 plus 1 is equal to 1 0. Carryover bits. When adding binary numbers, a carryover is produced when the sum equals or exceeds 2, and this becomes a carry bit for any next column to be added, and so on.
I will give you some examples for you to easily understand what binary addition and carryover bits is. Now let's start with our first examples. Our first example is 1 0 plus 0 1. If we add this, we will get 0 plus 1 is 1, and 1 plus 0 is 1. For us to know if our answer is correct, we will know the decimal value of this binary. So first, we have here the 2 and 1. 4. So 1 0. So the values that have 1 under is the 2 plus 0, meaning this is 2. So 1 0 is equal to 2. And 0 1 is equal to 0 plus 1, which is 1. So basically, it's 1. And we all know that 2 plus 1 is 3. So we need to check if 1 1 is equal to 3. How? We write 1 here and also 1 here. So basically, it's 2 plus 1 is equal to 3. So 2 plus 1 is 3, and 1 1 is also 3. So 1 0 plus 0 1 is 1 1, and 2 plus 1 is 3. And 1 1 is equal to 3. So we have the correct answer. Now let's proceed with our next examples. Example, we have 1 0 1 plus 0 1 1. Okay, 1 plus 1 is 1 0. Why? Because if we use also the decimal value of this binary, 1, 0. So we have 1 here and we have 0 here. So 2 plus 0 is equal to 2. Basically, 1 plus 1 is 2. Kaya that's why 1 plus 1 is 1, 0. Because 1, 0 is equal to 2. Now, 0 plus 1 is 1. Plus 1 is 1, 0. And 1 plus 0 is 1. Plus 1 here is 1, 0 again. So 1, 0, 1 plus 0, 1, 1 is equal to 1, 0, 0, 0. Now let's go with our next example, which is 1, 0, 1, 0 plus 1, 1, 0, 1. 0 plus 1 is 1. 1 plus 0 is 1. 0 plus 1 is 1. And 1 plus 1 is 1, 0. Now let's have some example. 1, 1, 1, 0, 1 plus 0, 1, 0, 1, 1. I want you to pause this video and try to answer these binary numbers for you to know if you really understand this lesson. And play again the video if you're done answering this. Okay. 1 plus 1 is 1, 0. 0 plus 1 is 1. Plus 1 is 1, 0. 1 plus 0 is 1. Plus 1 is 1, 0. 1 plus 1 plus 1 is 1, 1. And 1 plus 1 plus 0 is also 1, 0. Okay, let's have some other example. We have 1, 0, 1, 1, 0, 0, 1, 0 plus 1, 0, 0, 1, 0, 1, 1, 0. 0 plus 0 is 0. 1 plus 1 is 1, 0. 1 plus 0 plus 1 is 1, 0. 1 plus 0 plus 0 is 1. 1 plus 1 is 1, 0. 1 plus 1 plus 0 is 1, 0. 1 plus 0 plus 0 is 1. And 1 plus 1 is 1, 0. Now, we're done in giving an examples on binary additions with carryover bits. I will also give an examples with fractional binary numbers. So how we will add the fractional binary numbers? So we have an example here, 1, 0, 0, 1 plus, binary point 0 plus 1, 1, binary point 1. 0 plus 1 is 1. Copy the binary point. Then 1 plus 1 is 1, 0. And 0 plus 1 is 1. Plus 1 is 1, 0. 1 plus 0 is 1. Then bring down 1. So basically, adding a fractional binary numbers is not different from adding a binary numbers, because in here we just bring down the binary point. So now let's have some other examples. We have 1, 1, 1, 0, binary point 1, 0, 1 plus 1, 0, 1, binary point 1, 1, 0. So if 1 plus 0 is 1, 0 plus 1 is 1, and 1 plus 1 is 1, 0. Then copy the binary point, then 0 plus 1 is 1 plus 1. Here we have 1, 0. 1 plus 1 plus 0 is also 1, 0. 1 plus 1 plus 1 is 1, 1. And 1 plus 1 is 1, 0. So our answer is 1, 0, 1, 0, 0, binary point 0, 1, 1. Now I will give you some examples on fractional binary system. Last example, you have 1, 0, 1, 1, 1, 0, binary point 1, 1, 0, plus 1, 1, 0, 0, 1, 1, binary point 0, 0, 1. 0 plus 1 is 1. 1 plus 0 is 1. 1 plus 0 is 1. Copy or bring down the binary point or the radix point. 0 plus 1 is 1. 1 plus 1 is 1, 0. 1 plus 0 is 1. Plus 1 is 1, 0. 1 plus 0 is 1. Plus 1, we have 1, 0. 0 plus 1 is 1. Plus 1 is 1, 0. 1 plus 1 is 1, 0. Plus 1, we have 1, 1. So our answer is 1, 1, 0, 0, 0, 0, 1, binary point 1, 1, 1. I hope you understand how to add the binary numbers and also the fractional binary number.
Binary subtraction. Binary subtraction is the process of subtracting binary numbers. Again, only the integers 0 and 1 are used. Binary subtraction is similar to the arithmetic operations of subtraction that we do with numbers. And like binary addition, it also has 4 rules for easy calculations. Rules of binary subtractions. 0 minus 1 is equal to 0. 0 minus 1 is equal to 1 with a borrow of 1. We all know in decimal that if we subtract 1 from 0 is negative 1, which is not applicable with binary. So we need to borrow from the next column. Then the next rules is 1 minus 0 is equal to 1 and 1 minus 1 is equal to 0. Borrow bits. Borrowing happens when the number being subtracted is greater than the number being subtracted from. The only time borrowing is required in binary subtraction is when 1 is subtracted from 0. When this happens, the 0 in the borrowing column actually becomes a 2. The 0 minus 1 becomes 2 minus 1 is equal to 1. While the 1 in the column being borrowed from is reduced by 1. If the next column is also 0, borrowing from the next column will be required until a column with a value of 1 can be reduced to 0.
Now, I will give you some examples of binary subtractions and borrow bits. Let's start with our first example. We have 1, 1, 0, 1 minus 0, 1, 0, 1. 1 minus 1 is 0. And 0 minus 0 is 0. 1 minus 1 is 0. And 1 minus 0 is 1. So 1, 1, 0, 1 minus 0, 1, 0, 1 is equal to 1, 0, 0, 0. Now, we will give you some other examples, which is 1, 0, 0 minus 1, 1. 0 minus 1 cannot be, or 0 minus is negative 1, but negative 1 is not applicable with binary numbers. So we will borrow to the next column, which is 0, but we can't borrow with 0. So we will borrow in the next column, which is 1. So 1 will become 0, and 0 will become 1, 0. And now we can borrow with 1, 0. So 1, 0 will become 1, and 0 has become 1, 0. 1, 0 minus 1 is 1. Because we all know that 1, 0 is equal to 2. So 2 minus 1 is 1. Now, 1 minus 1 is 0. And bring down 0. So 1, 0, 0 minus 1, 1 is equal to 0, 0, 1. Now, let's proceed with another example. So we have the 1, 0, 0, 0 minus 1, 0, 1. 0 minus 1 cannot be. We will borrow with 0, but we can't. With 0, we can't. So we will borrow from 1, so it will become 0. And it will become 1, 0. Now it will become 1 for it to become 1, 0. And now it also will become 1 for it to become 1, 0. So 1, 0 minus 1 is 1. 1 minus 0 is 1. 1 minus 1 is 0. Then bring down 0. So 1, 0, 0, 0 minus 1, 0, 1 is 0, 0, 1, 1. Now, let's have our fourth example, which is 1, 0, 0, 1, 0 minus 0, 1, 0, 1. 0 minus 1 cannot be or negative 1, which is not applicable with binary, so it will become 0 for it to become 1, 0. 1, 0 minus 1 is 1. 0 minus 0 is 0. 0 minus 1 cannot be, and you can't borrow from 0, so we will borrow from 1 to become 0, and it will become 1, 0. Now we can borrow from 1, 0, it will become 1, and it will become 1, 0. 1, 0 minus 1 is 1. 1 minus 0 is 1. And bring down 0. So our answer is 0, 1, 1, 0, 1. Okay. Let's have some other example. Then I want you to post this video for you to answer this last example. Then play the video again for you to check if you have the same answer. So we have 1, 1, 0, 1, 0, 1, 0, 1 minus 0, 1, 1, 0, 1, 0, 1, 0. So 1 minus 0 is 1. 0 minus 1, negative 1 cannot be, so it will become 0, and it will become 1, 0. 1, 0 minus 1 is 1. 0 minus 0 is 0. 0 minus 1 cannot be, so we will borrow from the next column, which is 1. So it will become 0, and it will become 1, 0. 1, 0 minus 1 is 1. 0 minus 1 is 0. 0 minus 1 cannot be. We will borrow from the next column. So it will become 0 and it will become 1, 0. 1, 0 minus 1 is 1. We will borrow again from 1. It will become 0 and it will become 1, 0. 1, 0 minus 1 is 1. And 0 minus 0 is 0. So our answer is 0, 1, 1, 0, 1, 0, 1, 1. I hope you got the correct answer. I will also give you an examples on how to subtract the fractional binary numbers. So our first example is 1, 1, 0. Binary point 1, 1 minus 1, 0, 0. Binary point 0, 1. So 1 minus 1 is 0. 1 minus 0 is 1. We also copy the binary point or the radix point in binary subtractions like the binary addition. So 0 minus 0 is 0. 1 minus 0 is 1. And 1 minus 1 is 0. So our answer is 0, 1, 0, binary point 1, 0. Now I will delete this for the next example. So we have the 1, 0, 1, 1, 0, 1, binary point 1, 0, 1 minus 0, 1, 0, 1, 0, 1, binary point 1, 1, 1. 1 minus 1 is 0. 0 minus 1 cannot be. We will borrow for 1. So it will become 0 and it will become 1, 0. 1, 0 minus 1 is 1. 0 minus 1 cannot be. We will borrow from 1. For the next column, it will become 0 and it will become 1, 0. 1, 0 minus 1 is 1. Again, copy or bring down the binary point or the radix point. Now 0 minus 1 cannot be. We will borrow from 0 but can. So we will borrow from 1. So 1 will become 0 and 0 will become 1, 0. Now we can borrow from 1, 0. So 1, 0 will become 1 and 0 will become 1, 0. 1, 0 minus 1 is 1. 1 minus 0 is 1. 0 minus 1 cannot be. We will borrow from the next column. It will become 0 and it will become 1, 0. 1, 0 minus 1 is 1. 0 minus 0 is 0. 0 minus 1 cannot be. It will become 0 and it will become 1, 0. 1, 0 minus 1 is 1 and 0 minus 0 is 0. So our answer is 0, 1, 0, 1, 1, 1, binary point 1, 1, 0. Now for our last example, we have 1, 0, 1, 1, 0, 1, 0, 1. Binary point 0, 1, 1, 0. Minus 0, 0, 1, 0, 1, 0, 1, 0. Binary point 1, 1, 0, 1. Okay. 0 minus 1 cannot be. We borrow from 1, it will become 0 and 1, 0. 1, 0 minus 1 is 1. 0 minus 0 is 0. 1 minus 1 is 0. 0 minus 1. We will borrow from the next column because we can't subtract 1 from 0. So it will become 0 and it will become 1, 0. 1, 0 minus 1 is 1. Copy or bring down the binary point or the radix point. 0 minus 0 is 0. 0 minus 1 cannot be. We borrow 1, so it will become 0 and it will become 1, 0. 1, 0 minus 1 is 1. 0 minus 0 is 0. 0 minus 1, we will borrow from 1, so it will become 0 and it will become 1, 0. 1, 0 minus 1 is 1. 0 minus 0 is 0. 1 minus 1 is 0. And 0 minus 0 is 0. And 1 minus 0 is 1. So our answer is 1, 0, 0, 0, 1, 0, 1, 0, 0.1001. I hope you understand on how to subtract the binary point, the binary numbers rather, and also the fractional binary numbers using the binary subtractions.
Binary multiplication. The process of multiplying binary numbers is known as binary multiplication. The process of multiplying binary number is the same as multiplying decimal values. It works in the same way as the traditional multiplication method. And like binary addition and subtractions, it also has 4 rules. The rules of binary multiplication is 0 times 0 is equal to 0, 0 times 1 is equal to 0, and 1 times 0 is equal to 0. And as you can see, every time you multiply a values or integers into 0, the answer is always 0. And the last one is 1 times 1 is equal to 1. And no borrow or carry over bits is applicable in the binary multiplication.
Now, I will give you some examples of binary multiplication for you to easily understand what it is. Now, let's go with the first example. 101 times 1, 1. 1 times 1 is 1. 1 times 0 is 0. And 1 times 1 is 1. As you can see, every time you multiply 1 to a binary number, we will just get the same binary value or binary numbers. So now let's multiply 1 to 101, which is also 101. Now, after multiplication, we know that we need to add this. So 1 is bring down, 0 plus 1 is 1, 1 plus 0 is 1, and bring down 1. So 101 times 1 is equal to 1111. Now, I will give you some other example. 1101 times 101. 1 times 1 is 1. 1 times 0 is 0. 1 times 1 is 1. And 1 times 1 is 1. 0 times 1 is 0. 0 times 0 is 0. 0 times 1 is 0. And 0 times 1 is 0. As you can see also, that every time you multiply 0 by a binary number or binary value, we will just get the 0 for all the value. So it's easy to multiply. So 1 times 1 is 1, 1 times 0 is 0, 1 times 1 is 1, 1 times 1 is 1. Now let's perform the addition. Bring down 1, 0 plus 0 is 0. 1 plus 0 plus 1 is 1, 0. 1 plus 1 plus 0 plus 0 is 1, 0. 1 plus 0 plus 1 is also 1, 0. And 1 plus 1 is 1, 0. So our answer in 1101 times 101 is 1000001. I will give you more example on binary multiplication. We have 0101 times 111. Basically, for an easy calculation, we just copy 0101 because it's all 1 here. So also the 1010 and also the 1010. I hope you understand why we just copy this in here. So 1 is bring down, 0 plus 1 is 1. 1 plus 0 plus 1 is 1, 0. 1 plus 0 plus 1 plus 0 is 1, 0. And 1 plus 0 plus 1 is 1, 0. 1 plus 0 is 1. So our answer is 10001, 1. Now let's have other example, and I want you to post this video for this example and try to answer this one. And play again the video if you are done answering this for you to check if we have the same answer. So 111010 times 101. So it will become 1 times 0 is 0. 1 times 1 is 1, 1 times 0 is 0. 1 times 1 is 1, 1 times 1 is 1, 1 times 1 is 1. So 0 times 0 is 0, 0 times 1 is 0, 0 times 0 is 0, 0 times 1 is 0, 0, and 0. So 1 times 0 is 1. So we will just copy this value because we will multiply it by 1. So it will become 0. Sorry, I'm wrong with this. So it's 0, it's 1, it's 0, it's 1, 1, 1. So now let's perform the addition. Let's bring down 0 here. Then 1 plus 0 is 1. 0 plus 0 plus 0 is 0. 1 plus 0 plus 1 is 1, 0. 1 plus 1 plus 0 plus 0 is 1, 0. And 1 plus 1 plus 0 plus 1 is 1, 1. 1 plus 0 plus 1 is 1, 0. And 1 plus 1 is 1, 0. So our answer is 1001, 0001, 0. I hope you got the correct answer. You have the same answer for this example. Now let's go with our last example for binary multiplications on binary numbers. Now it's 11010 times 1101. Okay, 1 times 0 is 0, 1 times 1 is 1, 1 times 0 is 0, 1 times 1 is 1, and 1 times 1 is 1. 0 times 0 is 0, 0 times 1 is 0, 0 times 0 is 0, 0 times 1 is 0, and 0 times 1 is 0. Now, let's multiply 1 by this value, so we will just get 0, 1, 0, 1, 1, and also 1 times for this value, so we will get the 0, 1, 0, 1, 1. And let's perform the addition. So we will just bring down 0 here. Then 1 plus 0 is 1. 0 plus 0 plus 0 is 0. 1 plus 0 plus 1 plus 0 is 1, 0. And 1 plus 1 plus 0 plus 0 plus 1 is 1, 1. And 1 plus 0 plus 1 plus 0 is 1, 0. And 1 plus 1 plus 1 is 1, 1. And 1 plus 1 is 1, 0. So in adding this binary number, we will just perform the binary addition. There's no special treatment here, even if it's binary multiplications. We will also include on how to do the binary addition. Now, this is our last example for the binary multiplications of binary numbers. Now, let's go with binary multiplication on fractional binary numbers. Now, let's perform the binary multiplication in a fractional binary number. So, our first example is 101 binary point 0 times 10 binary point 1. 1 times 0 is 0. 1 times 1 is 1. 1 times 0 is 0. And 1 times 1 is 1. 0 times 0 is 0. 0 times 1 is 0. 0 times 0 is 0. And 0 times 1 is 0. And 1 times this value, we will just copy the value. So it will become 0, 1, 0, 1. Then perform the addition. Now bring down 0. Then 1 plus 0 is 1. 0 plus 0 plus 0 is 0. 1 plus 0 plus 1 is 1, 0. And 1 plus 0 plus 0 is 1. Then bring down 1. So our answer is 1, 1, 0, 0, 1, 0. But it's not our final answer because as we can see, we have the binary point here. So we will just count the move to get from the binary. So 1, 2. So we will also count in the final answer 2, 1, 2. Then it's a binary point. So our answer is 1, 1, 0, 0, binary point 1, 0. Now for our next example, we have 1, 1, binary point 0, 1 times with itself 1, 1, binary point 0, 1. 1 times 1 is 1. 1 times 0 is 0. 1 times 1 is 1. 1 times 1 is 1. 0 times 1 is 0. 0 times 0 is 0. 0 times 1 is 0. And 0 times 1 is 0. Then 1 times this value is 1, 0, 1, 1. Then 1 times this value is also equal to 1, 0, 1, 1. Now let's perform the addition again. So you just bring down 1. Then 0 plus 0 is 0. 1 plus 0 plus 1 is 1, 0. And 1 plus 1 plus 0 plus 0 plus 1 is 1, 1. And 1 plus 0 plus 1 plus 0 is 1, 0. And 1 plus 1 plus 1 is 1, 1. Then 1 plus 1 is 1, 0. Now, let's count again. 1, 2, 3, 4. So we have 1, 2, 3, 4. So our final answer is, here is 1, 0, 1, 0, binary point 1, 0, 0, 1. Now, let's have our last example for binary multiplications involving a fractional binary number. 1, 0, 1, 1, binary point 0, 1 times 1, 0, binary point 1, 1. You can also post this video for you to answer this example. Then later on, play again this video for you to check if you have the same answer. So 1 times 1 is 1. 1 times 0 is 0. 1 times 1 is 1. 1 times 1 is 1. 1 times 0 is 0. 1 times 1 is 1. So copy again for multiplying 1 to this value. 1, 0, 1, 1, 0, 1. And multiplying 0 with binary numbers or for this value, we will get 0 for all the binary numbers. Now, multiplying 1 to this value, we will get the same, which is 1, 0, 1, 1, 0, 1. Now, let's perform the addition. So, bring down 1. 0 plus 1 is 1. 1 plus 0 plus 0 is 1. 1 plus 1 plus 0 plus 1 is 1, 1. 1 plus 0 plus 1 plus 0 plus 0 is 1, 0. And 1 plus 1 plus 0 plus 0 plus 1 is 1, 1. And 1 plus 1 plus 0 plus 1 is 1, 1. And 1 plus 0 plus 0 is 1. And bring down 1. 1, 2, 3, 4. Then 1, 2, 3, 4. So our final answer is 1, 1, 1, 1, 0, binary point 1, 1, 1, 1. I hope for giving some example or a few examples, you learn how to apply the binary multiplications in a fractional binary number.
Binary division. The binary division operation is similar to the decimal system. There are several ways to solve division operations. One of them is long division, which is the simplest and most efficient method. We also have rules in binary divisions. The first one is 1 divided by 1 is equal to 1. 1 divided by 0 is meaningless, and 0 divided by 1 is equal to 0, and 0 divided by 0 is also meaningless.
Now I will give you some example for you to easily understand what a binary division is and how to perform the binary divisions in the whole binary numbers and fractional binary number. So let's go with our first example, which is 1, 1, 1, 1. Divide by 1, 1. Is 1, 1 greater than or equal to 1, 1? Yes. So we will just put 1 here, and 1 times 1, 1 is 1, 1. And now let's perform the subtraction. 1 minus 1 is 0, 1 minus 1 is 0. So now let's bring down the next value, which is 1. Is 1 greater than or equal to 1, 1? No. So we will put 0 here, and 0 times 1, 1 is 0, 0. Now let's perform the subtraction. 1 minus 0 is 0. Now, let's bring down the another one here. So it will become, okay, it's not 0, it's 1, rather. So 1 minus 0 is 1. So now let's bring down another one here. Is 1, 1 greater than or equal to 1, 1? Yes. So it's 1. 1 times 1, 1 is 1, 1. Perform the subtraction, we will get 0. So 1, 1, 1, 1, 1 divided by 1, 1 is equal to 1, 0, 1. Now let's proceed with our next example. We have 1, 0, 0, 0, 0, 0, 1 divided by 1, 0, 1. So 1, 0, 1 and 1, 1, 1 and 1, 0, 0, 0, 0, 0, 1. Is 1, 0, 0, 0 greater than or equal to 1, 0, 1? Yes. So we will put 1 here. As you can see, we just use 1 and 0 in our quotient because this is a binary number. So meaning we will just have a two integer, which is 0 and 1. That's why 1 and 0 is the only applicable quotient in here. So 1 times 1, 0, 1 is basically 1, 0, 1. Now let's perform the subtraction. 0 minus 1 cannot be. So we will borrow from the next column. So 0 is not applicable, 0 is also not. So 1 will become 0, it will become 1, 0, and it will become 1 for it to become 1, 0. And it also become 1 for it to become 1, 0. 1, 0 minus 1 is 1. 1 minus 0 is 1. 1 minus 1 is 0. And bring down 0. Now let's bring the 0 here. Now 1, 1, 0. 1, 1, 0. 1, 1, 0 is greater than or equal to 1, 0, 1. Yes. So we will put 1 here. So 1 times 1, 0, 1 is basically 1, 0, 1. Now let's perform the subtraction. So 0 times 0 minus 1 cannot be, so we will borrow here. So it will become 0. And it will become 1, 0. 1, 0 minus 1 is 1. 0 minus 0 is 0. And 1 minus 0. 1 minus 1 rather is 0. Now let's bring down another integer here, which is 0. Now the question is 1, 0 greater than or equal to 1, 0, 1? No. So we will find 0 here. And 0 times 1, 0, 1 is basically 0, 0, 0. And 0 minus 0 is 0. And 1 minus 0 is 1. Now let's bring down another integer here. So it will become 1, 0, 1. Is 1, 0, 1 greater than or equal to 1, 0, 1? Basically, yes. So we will put 1 in our quotient. Then 1 times 1, 0, 1 is equal to 1, 0, 1. So it will become 0. So our final answer is 1, 1, 0, 1. Now, for our last example on performing binary multiplication in a whole binary number. So we have 1, 0, 0, 0, 1, 1 divided by 1, 0, 1. Is 1, 0, 0 greater than or equal to 1, 0, 1? No. So we will put 0 here. So 0 times 1, 0, 1 is basically 0, 0, 0. Then perform the subtraction. 0 minus 0 is 0. 0 minus 0 is 0. 1 minus 0 is 1. Now let's bring down another integer here, which is 0. Now 1, 0, 0, 0 is greater than 1, 0, 1. So we will put 1 here, and 1 times 1 is 1. 1 times 0 is 0, and 1 times 1 is 1. So perform the subtraction again. So we will get 0 minus 1 cannot be, so we can borrow from 0, 0. So we will borrow from 1 and it will become 0. For it to become 1, 0. Then 1, 0 will become 1. For it to become 1, 0. And 1, 0 will become 1. For this to become 1, 0. Now we can subtract 1, 0 minus 1, 1. 1 minus 0 is 1. 1 minus 1 is 0. And bring down 0. Now let's bring down another integer here, which is 1. Is 1, 1, 1 greater than or equal to 1, 0, 1? Yes. So we will put 1 here, and 1 times 1, 0, 1 is 1, 0, 1. Then perform the subtraction again. 1 minus 1 is 0, 1 minus 0 is 1, and 1 minus 1 is 0. Then bring down another integer here, which is 1. Is 1, 0, 1 greater than or equal to 1, 0, 1? Yes. So we will put 1 here, and 1 times 1, 0, 1 is basically 1, 0, 1. And 1, 0, 1 minus 1, 0, 1. Or 1 minus 1 is 0. 0 minus 0 is 0, and 1 minus 1 is 0. So basically, our quotient here is 0, 1, 1, 1. Now, let's proceed with binary multiplication involving a fractional binary number. So our first example is 1, 1, 1. Binary number 1, 0 divided by 1. Binary point 1. Binary point value. So, in dividing a fractional binary number, we will just ignore a binary point. So it will become 1, 1, 1, 1, 0 divided by 1, 1. So I will erase this, guys. Now let's proceed. Is 1, 1 greater than or equal to 1, 1? Yes, so it will become 1. 1 times 1 is 1, 1 times 1 is 1. Perform subtraction, we'll get 0 here. 1 minus 1, 0, 1 minus 1, 0. Now, let's bring down 1 here. Is 1 greater than or equal to 1, 1? No. So we will put 0 here, and 0 times 1, 1 is basically 0, 0. Perform the subtraction, 1 minus 0 is 1, 0 minus 0 is 0. So now let's bring down another integer here, which is 1. Is 1, 1 greater than or equal to 1, 1? Yes. So we will put 1 here. 1 times 1, 1 is 1, 1. Perform the subtraction, 1 minus 1, 0, 1 minus 1, 0, and bring down another integer here, which is 0. Which basically, we got the 0, 0, 0 here, but can also perform the division. So, is 0, 0 greater than or equal to 1, 1? Basically, no. So, it will become 0. And 0 times 1, 1 is 0, 0. Basically, it becomes 0. And our final answer, or our quotient, is 1, 0, 1, 0. That's all. We just ignore a binary point. Now let's proceed with another example, which is 1 binary point 1 divided by 1, 0. As you can see, we have a binary or a fractional binary number here, and we have a whole binary number. In dividing these two, we can divide a fractional to a whole binary number. So we will make this whole binary number become a fractional binary number. So 1 binary point 1 divided by 1, 0 binary point 0. Now let's perform the division. But first, let me erase this. So our given is 1, 1 divided by 1, 0, 0. Because our given is this. So we just ignore a binary point. Now let's perform division. Is 1, 1 can be divided by 100 or 1, 0, 0? Basically, no. So we will just put 0 and decimal or binary decimal here. Then we add here a 0. Now, is 1, 1, 0 greater than or equal to 1, 0, 0? Yes. So we will put 1 here, and 1 times 1, 0, 0 is 1, 0, 0. Now perform the binary subtractions. 0 minus 0 is 0. 1 minus 0 is 1. 1 minus 0 is 0. Now, we can also put another 0 here. So bring down 0 here for us to get the 0 as the last. So is 1, 0, 0 greater than or equal to 1, 0, 0? Yes. So we will put 1 here, and 1 times 1, 0, 0 is 1, 0, 0. Then perform this binary subtraction. 0 minus 0 is 0. 0 minus 0 is 0. 1 minus 0 is 0. Now our quotient is 0, 1 binary point then 1, 1.
All you gotta do is shake it. Ay, 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 so sexy. To keep the guys going wild. Everybody.
Sing it, you can move. Sing it, you can move. You can move all around. Sing it, you can move. Sing it, you can move. You can move to the top.
Now, let's proceed. We're going to talk about how to express negative numbers in binary using the sign magnitude method and two's complement method. And later in this video, we're going to talk about how to perform the operations in negative number of binary using the two's complement. So let's say we want to write negative 5 as a number. How will we do that? So we're going to start with the sign magnitude method in order to express negative 5. So we need to find out what 5 is, and we're going to use a 4-bit binary to do so. So it's 2n minus 1, which is 2, 4 minus 1, which is 2 to the third. Basically, it's 8. So we will use 8, 4, 2, and 1. So to get the 5, we all know that 4 plus 1 is 5. So we will put 1 here and then 0, 0 here. So for us to get the negative 5, in sign magnitude, the first 3 number represent a sign magnitude. Sign magnitude. And this 0 correspond to sign bits. So if the last number is 0, we're dealing with positive. And if this number is 1, we're dealing with negative. So to express negative 5, we just need to replace this 0 with 1. So using the magnitude method, negative 5 is gonna be 1, 1, 0, 1. Now let's work on some other examples using the sign magnitude method. Let's express the following negative numbers in binary. Negative 6 and negative 11 using a 5-bit. Basically 2 to the n minus 1, 2 to the fifth minus 1 is 2 to the 4, which is 16. So right here the 16, the 8, the 4, 2, and 1. To express the negative 6, we just need to know the binary number of positive 6. So basically positive 6 is 4 plus 1, 4 plus 2 rather. So we will put 1 under the 4 and 2, and 0 to 1, 8, and 16. Now, to get the binary number of negative 6, first we just need to copy the sign magnitude and then change the 0 or the sign bits to 1. Now, let's work with positive 11. So 11 is equal to 8 plus 2 plus 1. So it will become 0 and it will become 0. And for us to get the negative 11, we just need to copy the sign magnitude and then change the sign bits 0 to 1. Now, if we will perform operation here, then we know that positive 6 plus negative 6, we will get 0. But we'll try to add this binary number if we will get 0. So we have 0, 0, 1, 1, 0 plus 1, 0, 1, 1, 0. 0 plus 0 is 0. 1 plus 1 is 1, 0. 1 plus 1 plus 1 is 1, 1. And 1 plus 0 plus 0 is 1. And 0 plus 1 is 1. So if it's 18, no, 16 rather, then it's 8, 4, 2, and 1. 16 plus 8 plus 4 plus 0 plus 0 is basically 28. As you can see, 28 is not equal to 0. What does it mean? So, this method of representing negative number, that is the sign magnitude method, is very easy and user-friendly method. However, it doesn't work very well for computers, especially when computers need to perform operations such as the additions or the subtractions. Let me give you an example on the addition of positive and negative numbers when a positive number has a greater magnitude. So for example, you have 8 plus negative 4. 8 plus negative 4 is 4. And 8 is equal to 1, 0, 0, 0 in binary number. And negative 4 corresponds to 1, 1, 0, 0. If we add this, 0 plus 0 is 0, 0 plus 0 is 0, and 0 plus 1 is 1, and 1 plus 1 is 1, 0. So, because we have only a 4-bit here and 4-bit here, our answer should be in 4-bit also. So, this 1 here will become cancelled. So, we have 0, 1, 0, 0. So, let's check if it's 4. So, if it's 8, then it's 4 and 2 and 1 will become 4 plus 0 plus 0, which is equal to 4. So, our answer is correct. Now, let's go with the second case. It's the addition of positive and negative numbers when a negative number has a greater magnitude. For example, if you have 1, 0, 1, 1, 1, 0 plus 0, 1, 1, 1, or 1, 0, 1, 1, 1, 0 is equal to negative 18 plus 7, you should have the answer of negative 11. So if you add 1, 0, 1, 1, 1, 0 plus 0, 1, 1, 1, 0 plus 1 is 1, 1 plus 1 is 1, 0, and 1 plus 1 plus 1 is 1, 1, and 1 plus 1 plus 0 is 1, 0, and 1 plus 0 is 1, bring down 1. So if you have 1, 1, 0, 1, 0 here, this is 1, this is 2, 4, and this is 8, 16, and 32. So this one here is we all know as assigned bit, and 1 corresponds to negative. So if this is negative 32 plus 16 plus 4 plus 1, we will get the value of negative 11. So meaning this 1, 1, 0, 1, 0, 1 is equal to negative 11. So we have the right answer. Now, let's go with our last case, which is the addition of two negative numbers. So if we have negative 8 plus negative 5, we should have answer of negative 13. And the negative 8 corresponds to this binary number 1, 1, 0, 0, 0, plus the negative 5 corresponds to 1, 1, 0, 1, 1. So if we add 1, 1, 0, 0, 0 plus 1, 1, 0, 1, 1, 0 plus 1 is 1, 0 plus 1 is 1, 0 plus 0 is 0, and 1 plus 1 is 1, 0. And 1 plus 1 plus 1 is 1, 1. So in this case, we have 5-bit binary, and it's also 5-bit binary. So we just need a 5-bit binary for our final answer. So we will cancel this one here. So it will become 1, 0, 0, 1, 1. Is 1, 0, 0, 1, 1 equal to negative 13? So let's check. If it's 1, 2, 4, 8, and 16, 16 here, but because 1 corresponds to negative, it will become negative 16. So if it's negative 16 plus 2 plus 1, basically it's negative 16 plus 3, which is equal to negative 13. So basically, 1, 0, 0, 1, 1 is equal to negative 13. So our answer for this is correct. Now let's proceed in subtraction or the binary subtractions involving negative number. So if you have 7 minus 4 and 7 corresponds to a binary number of 0, 1, 1, 1 minus 0, 1, 0, 0. In subtracting subtracting a negative binary numbers, we change these 4 to negative 4, then perform the addition. So to get the negative 4 of these 4, we will use the 2's complement. So if this is 1 or 0, 1, 0, 0, to get the second complement of this, we will get the first complement first. So change every 0 to 1 and every 1 to 0. So it will become 1, it will become 0, it will become 1, 1. This is our first complement. But to get the seconds or the 2's complement, we need to add 1. It will become 1 plus 1 is 1, 0. 1 plus 1 is 1, 0. 1 plus 0 is 1, and it will become 1 also. So this corresponds to negative 4. Now, let's perform the addition. So if this is 0, 1, 1, 1 plus this is 1, 1, 0, 0. So our answer will become 1 plus 1 is 1. 1 plus 0 rather. 1 plus 0 is 1. 1 plus 0 is 1. 1 plus 1 is 1, 0. And 1 plus 0 plus 1 is 1, 0. Now, because this is a 4-bit and this is a 4-bit, we just need the 4-bit also. So we will cancel this 1 bit. So our answer will become 0, 0, 1, 1. Basically, if this is 8, 4, and 2, 1, 2 plus 1 is equal to 3. And 7 minus 4 is also equal to 3, meaning we have the correct answer. Now, let's go with the next case. If we subtract 7 minus -4, -4 guys. 7 corresponds to 0, 1, 1, 1. And minus 1, 1, 0, 0. So we need to change the -4 to 4, then perform the addition. We use the seconds complement to get the 4. So in getting this, we will become 1, 1, 0, 0. Then to get the first complement, we change every 0 to 1 and every 1 to 0. So it will become 1, 1, 0, 0. So to get our seconds complement, we need to add 1. So 1 plus 1 is 1, 0. 1 plus 1 is 1, 0. 1 plus 0 is 1. And bring down 0. Now we get the value for positive 4. We can now perform the addition. So 0, 1, 1, 1 plus 1, 0, 0 or 0, 1, 0, 0, which is equal to 1, 0, 0. Then 1 plus 0 is 1. 1 plus 0 is 1. 1 plus 1 is 1, 0. 1 plus 0 plus 0 is 1. So you need to check if 1, 0, 1, 1 is equal to the subtractions of 7 minus -4. So basically 7 minus -4 is 11. So if it's 1, 2, 4, and 8, 8 plus 2 plus 1 is equal to 11. So we have the correct answer. Basically, this is not -11 because 7 minus -4 is equal to 7 plus 4, which is in binary addition. We not change this into -8. Basically, it's 8 plus 2 plus 1, which is 11. And this is also 11. So we have the correct answer. Now, let's proceed with our example number 3, which is -8 plus 5. So -8 corresponds to the binary of 1, 1, 0, 0, 0, and 5 is equivalent to 0, 0, 1, 0, 1. If we add 1, 1, 0, 0, 0 plus 0, 0, 1, 0, 1, it will become 0 plus 1 is 1, 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, and 1 plus 0 is 1. So, -8 plus 5 is equal to 3, or -3 rather. And 1, 1, 1, 0, 1, is it equal to -3 or not? Let's check. If it's 1 and this is 2, 4, 8, and 16. -16 plus 8 plus 4 plus 1 is equal to -3. So basically, our answer is correct. Now, let's go with our example number 4. So if we have here a -3 minus -6, -3 is equal to the binary number 1, 1, 0, 1, and -6 is equal to 1, 0, 1, 0. If we perform subtraction here, we will have 1, 1, 0, 1 minus 1, 0, 1, 0. So basically, 1 minus 0 is 1. 0 minus 1 cannot be, so it will become 0, and it will become 1, 0. 1, 0 minus 1 is 1. 0 minus 0 is 0. And 1 minus 1 is 0. So let's check if 0, 0, 1, 1 is equal to positive 3 because negative 3 minus negative 6 is equal to positive 3. So if this is 0, 0, 1, 1, it will become 1, 2, 4, and 8. Basically, if you add 2 plus 1, you get 3. So 3, 1, 2, 3. So we have the correct answer. Now, let's proceed to the example of binary multiplication involving a negative binary number. So, our first example is negative 6 times positive 7. So, negative 6 corresponds to the binary number of 1, 0, 1, 0 times positive 7 is 0, 1, 1, 1. So, 1 times 0 is 0. 1 times 1 is 1. 1 times 0 is 1, or 0 rather, and 1 times 1 is 1. 1 times this value will also get 0, 1, 0, 1. And 1 times this value will also get 0, 1, 0, 1. And 0 to this value, we will get the 0 for all. Now, if we have here a 4 bits, and we also have 4 bits here, we need 8 bits for our product. So, the number of bits of the product should be equal to the sum of the number of bits of the multiplicand and multiplier. In order to arrive to the expected number of a bit of a product, we need to extend the sign bits of the partial products up to the sum of the number of the bits of the multiplicand and multiplier. So if you have 4 here, we will add, if it's 1, we will add 1, 1, 1, 1. So basically, it's equal to 8. And if it's 1, we will add 1, 1, 1 here, and 1, 1 here. And because this is 0, we will add 0 here. Now, we can perform the addition. So, we will bring down 0 here, and 1 plus 0 is 1. 0 plus 1 plus 0 is 1. 1 plus 0 plus 1 plus 0 is 1, 0. And 1 plus 1 plus 1 plus 0 plus 0 is 1, 1. 1 plus 1 plus 1 plus 1, which basically in decimal is 4, which is equivalent to binary of 1, 0, 0. So our answer will become, we will put here 1, 0, and we will put here the 0. Now, 0 plus 1 plus 1 plus 1 is 1, 1. Now, 1 plus 1 plus 1 plus 1 plus 1, which is equal to 5. And basically 5 is equal to 1, 0, 1. So our answer is 1, 0, 1. But because this is only 8-bit, we will just put only the 8-bit. So 1, 2, 3, 4, 5, 6, 7, 8. So we will cancel the 1, 0 here. So our answer is 1, 1, 0, 1, 0, 1, 1, 0. Now let's proceed with our next example. We have the 6 times negative 7. So 6 corresponds to 0, 1, 1, 0 times negative 7, which is 1, 0, 0, 1. In here, if the negative 7 or the negative number is greater than the positive number, the partial product of this part, we will get the second complement. So now let's multiply first, and later I will discuss it. So 1 times 0 is 0. 1 times 1 is 1. 1 times 1 is 1. And 1 times 0 is 0. Now 0 times 0 is 0. 0 times 1 is 0. 0 times 1 is 0. And 0 times 0 is 0. Now 0 times this value is, we will get all 0. And 1 times this value, we'll just copy the value, which is 0, 1, 1, 0. But as I said earlier, that we will change this value to its second complement. Meaning, if it's 0, 1, 1, 0, and its first complement is to change every 0 to 1 and every 1 to 0, it will become 1, 0, 0, 1. And to get the second complement, we will add 1. 1 plus 1 is 1, 0. 1 plus 0 is 1. Bring down 0 and bring down 1. Now, we have the second complement. We will write it here. So, we will erase this part and we will change that into 0, 1, 0, 1. Now, if it's 4-bit and this is 4-bit, which is 8-bit, we will put 0, 0, 0, 0. And let me just erase this part. And it will become 0, 0, 0, 0, 0, 0, and 1. Now, we can perform the addition. Now, we can bring down 0 here, and 1 plus 0 is 1. 1 plus 0 plus 0 is 1. 0 plus 0 plus 0 plus 0 is 0. And 0 plus 0 plus 0 plus 1 is 1. 0 plus 0 plus 0 plus 0 is 0. And 0 plus 0 plus 0 plus 1 is 1. And 0 plus 0 plus 0 plus 1 is also 1. So our final answer here is 1, 1, 0, 1, 0, 1, 1, 0. Now, let's go with our last example for this, which is the both negative. We will multiply the negative 6 times 2 negative 7. Okay. The negative 6 is 1, 0, 1, 0 times the negative 7 is 1, 0, 0, 1. So 1 times 0 is 0. 1 times 1 is 1. 1 times 0 is 0. And 1 times 1 is 1. And 0 times this value, we will get 0, 0, 0, 0. And then 0, 0, 0, 0 again. Then now 1 times this value, we will get the 0, 1, 0, 1. But because this is a negative, we will also do the second complement of the last partial product, which is 1, 0, 1, 0. So it will become 0, 1, 0, 1, then add 1. 1 plus 1 is 1, 0. 1 plus 0 is 1. Bring down 1 and bring down 0. So let me erase this part and make it 0, 1, 1, 0. And now we can, if it's 4-bit and this is 4-bit, we need 8-bit. So we will write it 1, 1, 1, 1, 0, 0, 0, 0, 0, 0. Now we can perform the addition. Let's bring down 0 here. 1 plus 0 is 1. 0 plus 0 plus 0 is 0. 1 plus 0 plus 0 plus 0 is 1. 1 plus 0 plus 0 plus 1 is 1, 0. 1 plus 1 plus 1 plus 0 plus 0 is 1, 1. And 1 plus 1 plus 0 plus 0 plus 0 is 1, 0. And 1 plus 1 plus 0 plus 0 plus 0 is 1, 0. So we just need 8-bit because the addition of 4-bit plus 4-bit is just 8-bit. So 1, 2, 3, 4, 5, 6, 7, 8. So we will cancel the 1 here. So our final answer will become 0, 0, 1, 0, 1, 0, 1, 0. So let's proceed with the binary division involving a negative binary number. So this is our last lesson for this video. So if you have here 1, 1, 0 divided by 0, 1, 0, we will write it as 1, 1, 0 divided by 0, 1, 0 is equal to what? 0. Now, is 11 greater than or equal to 1, 0? Or 1, 1 is greater than or equal to 1, 0? Yes. So we will put 1 here and 1 times 1, 0 is 1, 0. Now, perform the subtractions. 1 minus 0 is 1. And 1 minus 1 is 0. Now, we can bring down 0 here. Is 1, 0 is greater than or equal to 1, 0? Yes. So we will put 1 here and 1 times 1, 0 is 1, 0. Now, we can perform the subtractions. 0 minus 0 is 0. 1 minus 0 is 0. Now, in binary division involving a negative binary numbers, this quotient, we will get the 2's complement of this quotient. If you have here 1, 1 or 0, 1, 1 equal to 1, 1, its first complement is to replace every 1 to 0 and every 0 to 1. So it will become 1, 0, 0. And to get the second complement, we will add this by 1. So basically, 0 plus 1 is 1. Bring down 0 and bring down 1. So here is our answer. But to check this, 1, 1, 0 divided by 0, 1, 0. 1, 1, 0 is basically negative 6. Divided by 2, 2. Because 0, 1, 0 is equal to 2. Which the answer that we need to get is the negative 3. Is 1, 0, 1 equal to negative 3? Let's see. If this is 4 and 2 and 1, and because this is 1, it will become a negative. So negative 4 plus 1 is basically negative 3. So we get the correct answer. Now, let's proceed with our last example, which is the negative 8 divided by the negative 4. So, the negative 8 is equal to 1, 1, 0, 0, 0 divided by 1, 1, 0, 0. First, we need to get the absolute value of this. So 1, 1, 0, 0, 0 divided by 1, 1, 0, 0. We will get the 8 here to get the absolute value of negative 8 and 4 here, which is 8 is basically equal to 1, 0, 0, 0 divided by 0, 1, 0, 0. So if we divide this, so it will become 1, 0, 0, 0 divided by 1, 0, 0. We will get here, is 1, 0, 0 greater than or equal to 1, 0, 0? Yes, so we will put 1 here, and 1 times 1, 0, 0 is 1, 0, 0, which is equal to 0 minus 0 is 0, 0 minus 0 is 0, and 1 minus 1 is 0. Now, we will bring down 0 here. 0, 0, 0, 0 is greater than or equal to 1, 0, 0. No, if we will put 0 here, 0 here, and 0 times 1, 0, 0 is equal to 0, 0, 0, which basically equal to 0. 1, 0. We have the 1, 0 here, and this is a 5-bit. We will put here, or we will make it 0, 0, 0, 1, 0, which is equal to 1, 0. Is 0, 0, 0, 1, 0 is equal to 2. And negative 8 divided by negative 4 is also equal to 2. So meaning we got the correct answer.